All right, here's the last video for this section. What we're going to do now is take what we've learned and apply it to a word problem that's like a real world situation. So here's our problem here. We've got the information we're given, the time that it takes a group of volunteers to build a playground varies inversely with the number n of volunteers. Okay, so the time in hours that it takes a group to build a playground, that it takes a group of volunteers to build a playground varies inversely with the number of volunteers. Okay, so we know, first of all, let's look right here. So we know that the time is equal to our inverse variation, our constant A, over the number of volunteers. So the time it takes varies inversely with the number of volunteers. We know that when we have time equal to 8, it takes 10 people. So what we're told right here, it takes a group of 10 volunteers, so n equals 10, 8 hours to build the playground. Okay, so we haven't even looked at our final, what we're supposed to do. We're just writing down the information as we get it. So our time that it takes a group of volunteers to build a playground varies inversely with the number of volunteers. T equals A over N. We know that when we have 10 volunteers, it takes 8 hours. Let's look at what we're doing. Make a table showing the time that it would take to build the playground when the number of volunteers is 15, 20, 25, and 30. What happens to the time it takes to build the playground as the number of volunteers increases? Okay, good information here. Let's go ahead and go through this. So first of all, we want to make sure that we understand the problem. So we're given a description of two different quantities that vary inversely, and we've got one pair of data values. Now, our plan is we're going to use the data that we were given. So the fact that we know it takes 10 volunteers 8 hours, we're going to use that to find the inverse, the constant of variation. Then we're going to write our inverse variation equation and then substitute the different values to get our table. So again, remember, we're trying to make a table showing the time it would take for 15, 20, 25, and 30 volunteers. So let's look first. Here's our general equation, like I wrote before, T equals A over N. A is your constant of variation, N is the number of workers, and T is the time. So now let's plug in what we know. We know that when T equals 8, N equals 10, we can multiply both sides and solve, and we get our constant of variation is 80. So now we plug it back in. Our equation is T equals 80 over N. So that's our inverse equation for the time it takes N workers to build the playground. Now we need to make our table of values. And if you remember, we want to make a table showing how long it's going to take for 15, 20, 25, and 30 volunteers. So let's go ahead and write this in first. So we'll make our table. N, these are the values we're going to plug in. So let's just go ahead and plug in. So 80 over 15, that gives us 5 hours and 20 minutes. That's 5 1/3. 20 over 80, or 80 over 20, that's 4 hours. 80 over 25, that's going to be 3 hours, and then 1/5, so that's going to be 3 hours and 12 minutes. 80 over 30 is going to be 2 hours. 2 2/3 is 2 hours and 40 minutes. So here's our table. So look what's happening. What do you notice? The second part asks, what happens to the time it takes to build a playground as the number of volunteers increases? So look what's happening. As more people are working, what do you see happening to the time? You should notice that it's going down. And this should make sense. Think about work. If two groups of people are doing the same job and one group has twice as many people, they're going to get done twice as fast as the other group. The group with more people is going to get the work done faster. So as the number of volunteers increases, the time it takes to build the playground decreases. That's your relationship right there. Okay, so again, steps are the same. For the word problem, you just have to understand it first, then make your plan, then go through and actually do your math. Set up your general equation, substitute in the data you know, find the constant of variation, and then use your equation to make the table of values. Now you're going to have a similar problem to work on right now. So what I want you to do, you've got this problem right here. So I'm going to have you write in a couple different things for your answer. What I want you to do when your text box, it's just going to be one single text box that shows up. I want you to first make a table. So before you make your table, I want you to write out your equation. So find your constant of variation. So you need to solve for A, find A, and write your equation. This is what you're going to have to do in your Edpuzzle question that's going to come up. Write your equation. Okay, so you're going to have equation y equals something. And then I want you to make a table showing the time it would take to roof a house when the number of workers 2, 6, 9, and 12. You don't have to make an actual table, but for the third part of your answer, I want to know what are your 4 values. So put them in order, separated by commas, like this. So when the number of workers is 2, what is your time when n equals 2? For the second one, what is your time when n equals 6? For the third one, what is your time when n equals 9? And for the fourth, what is your time when n equals 12? So your answer, don't worry about B. Okay, I'll be able to tell that as we look at your numbers. But I want to know, what are your 4 times when the number of workers increases from 2 to 6 to 9 to 12? Okay, so just like we solved before, I want you to go ahead and answer these questions, put them all, again, you're going to find A, write your equation, and then for the third part, give me the 4 times as your workers increase from 2 to 6 to 9 to 12.